do those CBTs, computer-based training, there's a lot of good information in there. There's a lot of good information going towards what you're studying and what you need for, even for Samsung, okay? Although it's generic for all brands, it still works even for Samsung, and there's a lot of good information. So I would suggest going back and looking at these CBTs. So we're going to go over some gas ranges, electric ranges, a little bit on microwaves. I want y'all to ask your questions at the end so we can get through this quickly. But let's get started, okay? So electric oven is a simple appliance that turns electrical energy into heat energy. Electric cooking appliances can be divided into two systems: control system and the heating system. Usually L1 and L2 both have 120 volts, 240 volts to run properly. Cycles and heating elements on and off in order to maintain a temperature range close to what you have set on your control thermostat, okay? So no matter where it is, whether it's going to be up here on your cooktop or in your oven, the thermostats in there will help control the temperature by turning it on and off to maintain a range within that temperature range, okay? The surface burners rely on a temperature sensor and an infinite switch in order to cycle and maintain proper temperature. So these switches up here on these ranges are not called potentiometers. They are infinite switches, so you gotta remember that term right there. It's very important to know that they're infinite switches and how they work. So you got the bake and broil heating elements. You can own these out. If they have a break in them, they have a bunch of corrosion on them, the resistance can change on these, and they may not be correctly working, okay? So as you own these out, you'll know if one of them's got a break or anything in it because it'll be an open load. Otherwise, they are a continuous filament heating element. So they will continue to put heat in there and out of there as it energizes and fires up and down as need be. Okay, so a heating element can fail over time with usage. Look normal, but no longer heat. It can short out and burn into. But again, sometimes they'll look fine on the top and not work at all. You need to be aware of that. You will also find in some of these ovens that there'll be a TCO up in the middle, underneath the back plate. If that TCO is burnt out, you're not going to get any controls up at the top. So if you don't see anything on your control board, look and see if it has a TCO and STG. Because if it does, it may just be the TCO. Then you can jump out that TCO, test your board, make sure everything works, and just order the TCO. But do not leave that jumped out. Okay? That's just for test purposes only. So make sure that you order the TCO so you can fix it properly. Instead of ordering a $300 control board, just order the TCO. Put the TCO in and you should be fine. Sometimes those TCOs wear out with time. So if they've been in there 5 or 6 years, wears out with time and breaks, that could be part of your problem. So look for that because they do have those on some of the ranges out there. And sometimes that's the quick and easiest fix. And sometimes it wouldn't be bad if you had an extra one on your truck. If they start getting truck stock, which we're talking about, it's always good to have little things like that so you're ready to go when something like that happens. Okay? Infinite switch reflects its infinity, okay, for variable inputs rather than being limited to a few switch levels. It sends voltage to the heating element by using a bimetal connector to cycle voltage on and off. Okay, a potentiometer will have different levels, and you can actually feel it click as it goes to each level. Kind of like an oscillating fan. You click it one, click twice, click third time, and it adds all those together for speed. These you can actually go in half intervals, okay? So on an infinite switch, you can go up between 1 and 2, and it's actually going to cycle between 1 and 2. Or if you go between 8 and 9, it's going to cycle and give that little extra energy that you think you need up there at 8 or 9. So an infinite switch has a constant connection, and it'll add more connections as it goes. So it just continuously adds more power as it goes through. That's how an infinite switch works.
Like a different switch.
Huh?
Like a different switch.
kind of like a light dimmer switch on your wall. You can push the button and turn it on, but then you can control the amount of power that you're getting into your light circuit, okay? But then again, a potentiometer is something like on an oscillating fan. You clicks to different speeds, okay? So that's why an infinite switch is a little bit different. An infinite switch will allow you to set the power control where you need it, to maintain heat, to warm, or do whatever function it's designed to do. Okay, you will notice on some of these infinite switches that you have double burners. You go to the right, you're doing the inside burner. You go to the left, you're doing both burners to add more heat. That's for instant boil, fast cook, and different things like that. So understand that each time you do that, you're going to change the wattage and the amperage that you're putting into those elements, okay? You go to the right, where it's only doing the one burner, you may get up to 4 to 7 amps. If you go left, you're going to get anywhere from 8 to 12 amps, depending on the size of the burners and the amount of amperage and wattage it requires for that particular part of the unit to work. So be aware of that. Some of the failures are that the surface element won't heat. The surface element goes too high in heat, no matter what the setting is on the switch. Those contacts of those infinite switches can get dirty, okay? So you can actually test that. If you go in there and it's all dirty, it's all corroded across that one, it may give you that same reading no matter where you put that switch.
This is the switch behind the knob?
This is the switch behind the knobs, yes.
Now, something we haven't discussed, but what about infestation?
Infestation's one of them.
I'm saying, I've been to many, and the stove is, surprisingly ain't walked off yet.
I've been to some that the stove did walk off.
But yeah, like, I've been told to call Samsung, they gotta record it, and so they can say yay or nay, but come on now.
9 times out of 10 on an infestation, Samsung will not cover it. Okay? Those type of infestations, you don't want to be in there anyway, because you don't want to get those in your tool bags or your clothes, take them home yourself. Okay? I stepped into a house one time just for a quick quote on the story. Something fell on my shoulder, I dusted it off, the roach hit the floor, and I looked up, there's a big pollen right up there, we're running all over each other. I stepped back out and left. I said, nope, y'all need to fix that before I come in there and fix that. So, F3 error code, display on a digital panel, will tell you that you have a surface element problem. And it could be even the surface indicator problem might be on there. Surface indicator light comes on and says it's hot all the time. It can still throw you that F3 code. So it could be within the element itself, it could be within the bimetal, or it could be in that little light that comes on there that says you got a hot surface.
Now, can't moisture?
You think the light will be
stay on
stuck on?
too?
See what now?
You said it could be the light.
Yeah,
You think
your
the
surface
bulb-
indicator light,
The bulb will just be stuck on.
it'll be stuck on, but that also goes a little bit through your bimetal. So it might just have a low energy level still
With a
going through
dim
your,
light, with a little dim light going.
Yep.
Can moisture make that light stay on too?
Moisture, yeah, because when you get a lot of steam or something in there, especially with a few steam clean your oven, sometimes you get a little moisture up under there, if it doesn't dry out good enough, it may cause a systematic short. It cause that problem, so. That doesn't happen very often, but I have seen it happen. Or somebody's poured a lot of water across the top while the burners were on and it poured a lot of steam up under there. So, yeah.
So error code F3, that's not an STG, so if that happens at a customer's home, how do we decipher what the trouble code is?
You what now?
F3 is not an STG, so that being said, if we're at a customer's home, we need to decipher what that trouble code means. How do we go about figuring that out?
Well, F3 is a generic code for most of your ranges, okay? Electrolux made that part, that F3 code is in there. But you gotta realize, you've got to look up the codes as per what STG shows you, okay? So when I say F3, it's pretty much a generic code across the industry, but that may still be some, Samsung does change those codes to what they want it to be. So it may be a E1 or an E3 or however they want to do theirs. You just need to look it up at STG and see what that error code is for that particular element, okay? Testing includes checking the proper voltage to the switch, isolating the switch and using the multimeter to test the continuity, and ohms on those, okay?
How much voltage goes to the infinite switch?
240 volts. You got L1 and L2 going to it, you'll need 240 volts. When you're in the customer's home, now here you're only gonna get anywhere from 204 to 208.
Right.
Okay? Temperature sensors. It's a thermistor that changes the resistance between the ambient temperature to control the reaction of what that switch is going to be. So whatever you tell the power to be, it's going to work to help maintain the temperature. That particular switch right there, sensor is going to be actually in your oven. Okay? So the symptom and failure of the temperature sensor may be the oven under or over cooks the food, and uneven cooking and times, okay? So the temperature sensor can be tested and isolated by the sensor and running a resistance check on it. One thing that you can do with these, and a lot of people's never even thought about it, you can actually take these out, check it at room temperature, and then hit it with your steamer for a little bit and see if the resistance changes without ever having to heat the oven up. Did y'all know you could do that with a steamer?
Nope.
You can
Makes
do that with a
sense.
heat gun, hair dryer, pull it out, heat it up, test it. Guess what? You don't burn yourself when you get the oven to change it out.
I had a batch of those where the two wires pulled out really easy,
Yep.
just breathing on it, so if you pull that out, it'll tug on that white insulation.
Yeah, don't tug on that white wires very hard because they do get brittle because they're getting heat to them and off and on, okay? So just be aware, there's a way to test that without heating up your oven and burning yourself when you go in there to change it out. If it's bad, use it the smart way. Use your steamer. You can just unplug it, take the two screws out, pull it out, test it out here. Guess what? You saved yourself a lot of time and a lot of effort.
Well, it makes sense, because you can stick a thermistor in ice cold water and get the temperature difference from that.
Yeah, same thing with a refrigerator thermistor, you can actually set it in the ice water and watch the temperature change. So you can check it at room temperature, put it in ice water, and see if the ohms change, and see if it fits with the ohms chart. Just ways to double check what you're testing and what you're doing while you're in the field. But I would recommend, highly recommend, that if you're going to test these, you just go ahead and take them out and test them real quick. Real simple, easy test. You've got a nice cool oven to work in. You replace the temperature sensor, test it, calibrate your oven, and off you go to the races. You've got your temp sensor fixed, okay? Now, these particular temp sensors are filled with a gas, so they use that little gas to expand and contract, and that's what changes the resistance of these. So make sure you know which one you have, and that you have the correct one in there, okay? Control boards. We have several different types of control boards, but they all basically work the same. So you use the buttons to set those on there. Again, like I told you, for that control board up there, there could be a TCO on the back of that oven. Make sure that TCO is working, because the power comes in, goes through the TCO, and then up there to your control board. If you don't have any power on your control board, don't just order a control board and leave. Check to make sure it doesn't have a TCO. That little $10 TCO is gonna be a whole lot cheaper than a $300 board. Okay? A lot less time, saves you a lot of time if you go find it and put it on there, okay? So if your oven won't turn on, it gets too hot, or it doesn't get hot enough, irregular functionality, so you can actually see if the time clock on it's not working correctly. If the temperature says it's 350 in there, but you actually take your K-probe off your meter and put it in there and it's only showing 275, you may have an issue. You may need to calibrate it. But how much can you calibrate that oven? It's plus or minus 35 degrees. It's a calibration level on it. So if you're only getting 275 in there, you may have a problem in your control board, or you may have a problem with your temp sensor. So you need to verify what the problem is and fix it. Okay? Electrical features such as the clock and timer may not function. The display shows an error code. Find out what your error code is and see what you need to do to fix it. Because your error code may come up and say your temp sensor's bad, your lower element, your bake element, or your broil element may be bad. So you need to know what you're looking for. Test the control board, consists of using a multimeter. And you can actually go to these pin connectors and check your elements, check your power to them. And then you can actually go to those and actually check the power at them and check them with ohms to see if you got a problem. Always double and triple check yourself before you go to replace something so that you know you get to the correct problem. Okay, we need a core problem so we have a core solution. That's just one thing you need to get familiarized with in your heads on that, okay?
Those LEDs go out sometimes.
Yes, those LEDs do go out sometimes. So if it goes out, you need to change that board out. Yeah. Okay? So, test the heating element circuit for continuity. You can actually, not like the way they did it here, you separate the one wire and you can actually test your amperage here, but then you can hang your meter up there and you can test for continuity just by testing your wires to the heating element. You can actually go right straight to the heating element and test it all the way through. You can get your ohms. Does anybody know what the basic ohms are for a heating element on a range?
3.5?
30 to 100?
30 to 100? No.
14 to 23? 18.
What?
Does it say right there?
14 to 23?
It could be 14 to 23, depending on the size of the oven. But most of your elements, even the heating coils in a refrigerator, are anywhere from 40 to 80 ohms. That's pretty standard across the industry for most many of them. I can tell you on these back here, they're gonna look right around 60, 63, something like that. Okay? But again, you gotta know what you're looking at. You gotta know what your power is. Okay? Oops, let's go back a few. Like it says right here, 14 to 23. That may be your upper broil one, while your oven one may be larger. Okay, because broil may be a lot smaller element. Okay? And then again, 240 volts from L1 and L2, but you need to know how the power goes through your circuit board and through your relays to get you that voltage. Okay? So that's just a few little troubleshooting deals. Make sure y'all take pictures of these so you have them. Okay? The electric oven does not heat. Like I said a while ago, it could be a break in it. Could be just a little split in it that's causing it not to heat. You can ohm these out. You can also test the power to them. You might also check the wires out here on the end where they might have melted and burned into. Okay? So just make sure you're following standard troubleshooting when you're doing these. You can test the power and the ohms from the board, but then go to the heating element, look at it, test it here, make sure you got good wires and everything, good connections and everything on that. Because I have seen the terminals on these burning too. Okay? Testing the heating element for continuity, use your multimeter. By now you are pretty familiar with how to test continuity in ohms, right? Okay, as they get more and more familiar to you, the more you use the meter. So make sure you're testing the continuity, make sure you're watching what you're testing on these, and that you got good continuity. I always tell everybody to check the ohms. If you got ohms coming through it, you have continuity. Okay, because it is a straight path. It starts on one end, comes around and goes back out the other. There is no break in that whatsoever. So if you have ohms, you have continuity. I always tell you to check the ohms so you can put down a reading. Okay, and guarantee you that continuity does not give you the correct ohms. So ohms will actually be a better test, okay? For good measure, you can check the ohm meter and test it. Make sure it's between 14 and 23 ohms. Again, that's only for your broil because it's going to be a smaller element than your bake. And your bake element is probably going to be around 60. Shorted heating element. can damage the relay on the control board. If it does that, if it gets a surge back because it broke in two, that relay can actually stick. You can actually tap that relay on the control board, and if it resets and tries to send power back down, then you know that you got a bad relay on your control board. You're gonna need the control board and the element. So just another way to test that, okay? Because sometimes you can tap it, it'll reset. Sometimes you tap it, it doesn't reset. You're still gonna have to replace the board. Okay? But you can check the relay at the board and see if it's got constant power going through it, it's probably stuck in the closed position. If it doesn't have power going through it, but it won't close, to get power down to the element, you still got a problem. You're gonna have to replace it. Okay, a faulty temperature sensor. We've already gone over the temperature sensor a little bit. We won't spend too much time on that. I've already told you some of the things that could be going wrong with it, so let's move on. So there's your temperature sensor. Like I said, you can test those outside of the cabinet without having to turn that oven on. Okay, know what the ohms are, know what the chart is. The chart, STG always lists the chart. Okay. You'll see what the type of ohms you have is 1,000 to 1,100 ohms of resistance at room temperature. And then it's going to go up. It could be up to anywhere from 1,300 to 1,654 ohms at 350 degrees. Okay? The boil heating element is the heating element up on top. They're not the easiest ones to get in and out, so be careful with them. Okay, because if you're putting those in there and you bend them, you could cause another issue. If you get them bent, they're actually touching up to the top of the cabinet up there, it's going to cause an issue. So make sure you put those in the correct way. You don't want to cause any direct shorts or direct heating current for those actually touching the top up there. So make sure they're in their brackets and stuff the way they need to be. They should turn to a bright red when they're heating and should go off and on as for what your temperature needs to be. You, like I said, you can ohm those out, you can isolate them, you can test them. Okay? This one says 15 to 75 ohms. Gas oven overview. You got your thermostat, your oven igniter, your safety valve, your ignition switch, control board, spark module, and then your separate igniters for your burners up here. Okay, your spark module, you can test. Did y'all test those by ohms or did you test those for the electricity yesterday?
Electricity was a pulse.
Electricity gives you a pulse.
So we did both resistance.
You did both resistance and test the pulse. Okay. That's a good way to test those, make sure they work. You got your power coming in, and then you have how many ports on the back of the one?
5.
5 ports. One to each burner assembly, if there's 5 burners, right? If you're 6, you're gonna have 6. If there's 8, you're going to have 8.
And you can troubleshoot by moving the wire around to a different port.
To see if it's gonna spark each one separately, right? Yep. Okay. Typical failures, no clicking sound, no combustion from the gas, set to ignite, and the gas is flowing. Okay, but you can take a manometer or a magnet helix and actually test the gas flow on these. And usually that's about 4 inches of displacement of inches in water column, so about 4 is what you need for a movement for these to properly work. Okay? Testing includes using a multimeter, going to voltage and isolating the module, and testing for continuity. Again, continuity is not a complete check. I always say check with ohms. The igniter. The igniter is used to open the gas valve once the igniter gets up to amperage. What is the average amperage going into the igniter? 3.3. That's usually about right, it's about 3.3 amps.
Full speed, and then obviously if it starts to glow, it's a lower number.
As it starts to glow or as it gets up to full power, the amperage actually drops, doesn't it? Okay? Does the igniter on a range ever go out? Huh? No.
The element can.
The gas goes on and off, but the igniter stays on. At a lower wattage, but it stays on. Because once you get up to temperature, and it needs to reignite to maintain that temperature, it's going to work off the thermostat. So when that gas comes out, it's going to automatically ignite because that igniter never goes off. That's different than a dryer. Dryer has a flame sensor. It turns on the igniter on and off as it needs to, and then puts the gas out as it needs to. But on a range, it's different, so you need to know how that operates or why that's important. Okay? That igniter never goes off. It goes up to full watts initially, and it comes down in watts, usually rests between 1.4 to 1.7, and it rests in that position. But when you already have your heat in there, you don't need as much heat or as much amperage to start the gas again. Okay? Because it's already warm in there.
You can measure the very low state, and then once it calls for more heat, it immediately starts rising.
Yep, it'll rise just a little bit, then go right back down into its idle setting, okay? So y'all need to know exactly how that works. It's very, very important how that igniter works in these, okay? You can test these for ohms, you can even test these for voltage and amperage, but amperage is the best way to test these because about 3.3 to 3.4 is where it's going to be at full power. And then you can actually, once the gas ignites, watch the amperage drop down, okay? Your thermostat works just like it does an electric oven, pretty much the same thermostat. It is going to basically tell the gas, I'm going to need more gas to warm it back up. Or it's going to shut down that solenoid when it doesn't need more, when it tells it it's at temp, okay? You can ohm these out, and again, the best way I say to test those, don't start your oven, use a heat gun or a steamer. You know if that ohms is changing, that sensor is okay. Okay? Safety valves. You have your gas safety valve, okay? Works in conjunction with the control board and the thermostat. All right? The only other thing that happens is when you initially turn it on, it's looking for the amperage coming back to the control board from your igniter to initially open that valve. Once that's done, it gets up to tip, the thermostat takes over, and it controls it from there. Okay, does everybody understand how that flows, how that works? Again, no gas or flow to the oven. A gas smell, when using the oven, strongest in the oven cavity. If you smell a gas smell, do you want to go in and start using the top of the ratings or trying to turn on the oven?
No,
You turn on the light switch.
no,
You use your cell phone.
no.
You don't use anything that can give any sign of static charge or static discharge of any way, form, or fashion. You don't turn on the ceiling fan and go open a window, you just go open a window and try to evacuate. You wanna set up an oscillating fan in there and turn that on? No, you know, anything that could give any type of static or charge to it that could cause ignition, you want to be able to evacuate that just right, okay?
Sometimes a weak or faulty igniter, they will call about a gas valve.
Yep.
It's just because it's taking too long to pop that.
Well, another thing that could cause a gas smell too is some of you pulled out the burn elements. What did you see on the end of those burner elements? On the end of the tube out there? What about the air gap? The air gap, if it's not mixed right, you're not getting a good flame, that can also give you a gas smell. Or an ambient smell off the CO2 gas that's not burning correctly out on the end, okay? So when you get a weird, awkward yellow tall flame, it's actually gonna put off a little bit of an odor. And
So
so people
on
are
your
going
oil flame, you would adjust that.
you would adjust that to get the better blue, hotter flame. sometimes your air gap can cause a little bit of that problem for the gas metal stuff. Your spark igniter, we've already gone over that a little bit. It actually sends the power to each. Now, does all of them spark?
Yeah.
Yep, they all spark. It just, when you open up that, infinite switch up there, you open the infinite switch up there, that infinite switch is gonna tell the gas to come on just to that burner. They're all going to spark, but just that burner's going to light. Okay? Can you change an individual
No.
igniter?
To the sun.
No, they come as an assembly, right? Well, that's not actually quite true.
On this one.
Each one of those has the orange wires that goes up to the deal. You can replace one at a time if you need to.
You can get a part number for each.
Yeah. But not all of it that way. Some of them are a complete harness assembly.
He's referring to that. Some of them, I think some you have to do them all.
Some of them come in a whole harness assembly, yes. But other of them, like a lot of these on the Samsung, they actually have one wire that comes in and goes up to each spark on the deal. Makes it a little easier. You just change one at a time. But be very careful with those because that ceramic does like to crack really easy. So you don't take them out, put them back in 2 or 3 times to try it because they will crack and break. You can actually isolate these, run a resistance test on them, or you can also move your power around and see if you can get each one to spark and see which one is bad. Okay? Control boards, we've already gone over control boards, so I'm not gonna spend too much time on this. Of course, if the control board's having an issue, we've already discussed what you can look for on those. Gas burner disassembly. So when you're taking a gas burner apart, how many parts are actually in this gas burner?
3?
3, 4.
At least 4, right? You got your cap, your diffuser, which is your little aluminum piece under there, right? What else you have?
The orifice.
Your orifice, your spark, and then your tubing for your gas, right? But the 4 primary things is going to be your cap, your diffuser, your spark module, okay? And of course, your orifice. And the orifice needs to be changed when you change your gases, right? So if you go from natural gas to LPG, then the orifice needs to be changed.
That's that little gold thing?
Yep, that's the little brass thing, yes.
Okay.
Okay? Remember that when you're doing that though, that aluminum tubing is very, very soft. And you can keep that and get a hole in it really quick. So you gotta make sure you have really good, strong control of that when you pop those out. I usually tell everybody if you can do it by loosening it first before you ever unscrew it from the top. Then you can unscrew it from the top, get something down in there because you're gonna have to drop that out to the side. It's really hard to, because you can't magnetize them, they're really hard to get a hold of. Then you get your other one in there, get it started, screw everything back up to the top, and then tighten it down so that you're not crimping that tubing. That's just the best practice on changing out those orifices. Okay? Gas burner doesn't light. Again, you can go to your infinite switch. You can go to your spark module. And you can go to the burner itself and see if something hadn't clogged it up. They do have little burner cleaning tools that actually cleans out the orifice. And you can brush down the diffuser for the gas. So they do have little cleaning kits that you can find out there for those. You walk into a house where they use a lot of grease, I've seen it so many times that the grease splatters everywhere.
You just get yourself down that orifice.
Yeah, if you get the little cleaning tool, it's actually got little brushes on it that actually helps clean it out and pull it out so that you're not knocking it down into the gas line. Okay?
Cleaning was customer's issue.
Cleaning is a customer issue, but you can tell them where to go to get that tool. Amazon actually has burner cleaning tools. Comes with a little brass water brush and a little tip to go down into the orifice and stuff. They get that on their own. A lot of things you'll also see on that diffuser is where it's got so much grease and buildup around there that it cannot get the spark, because it does spark against that diffuser. That's why you have an aluminum diffuser there, so it'll actually take and enhance that spark. So if you don't get that area cleaned, at least you can take a little flat blade screwdriver, clean that off so you get their spark, at least get it ignited until they can actually clean it. Okay? Gas burner doesn't light, again, we just went over that, so. Major applies for microwave troubleshooting, let's go a little bit into that. The learning objectives here is how to properly troubleshoot a microwave. Okay, microwaves use a standard 120 volts. They need much more power for the magnitude